Let's do one more. This time with g of x being 2x to the fourth minus x cubed plus 7x squared minus 4x minus 4. First, we're going to come up with our list of all of our possibilities. The first one, coming from this 4, is going to be plus or minus 1, plus or minus 2, plus or minus 4. Those are all of our possible numerators. The denominator is going to be factors of 2. So that means we'll have plus or minus 1 or 2. Listing them all out, if they all had a denominator of 1, that'd be plus or minus 1, plus or minus 2, plus or minus 4. And if they all had a denominator of 2, that'd be plus or minus 1/2. 2 halves is 1, already on the list, and 4 halves, 2, which is also already on the list. So next, we start trying. Okay. So I'm going to take 2, -1, 7, -4, -4, and let's do some synthetic division. Start with 1. 2 minus 1 is 1. 1 plus 7 is 8. 8 minus 4 is 4. And 4 minus 4 is 0. So we have it factored, at least one factor right now, where g of x can be written as x minus 1 times 2x to the third plus x squared plus 8x plus 4. And we'll factor by parts again, cutting this part in half. Out of the front half, we can take out an x squared, and we'll be left with 2x plus 1. Out of the second half, we can take out a 4, and we're left with 2x plus 1. So to factor completely, first I'll take out 2x plus 1 and be left with x squared plus 4. And we'll take out the 2. And 2x plus 1, when we divide out the 2, will become x plus 1/2. And x squared plus 4, that factors into the two imaginary factors of x plus and x minus 2i. Remember, that comes from x squared plus 4 has to equal 0. X squared has to be -4. And when we take the square root of that, that's where we get plus or minus 2i. Anyway, now that it's completely factored, we can identify the zeros as being at 1, -1/2, -2i, and positive 2i. So there's all 4 of our zeros, and this line is where g of x is factored completely. And now we're done. All right, let's find all the zeros of f of x equals x to the fourth plus 3x to the third minus 3x squared plus 3x minus 4. All right, this is kind of everything put all together. And the first thing that we should do is come up with a list of possibilities. Remember that if there are any rational zeros, the numerator is going to come from that 4. It's going to be a factor of 4, and the denominator is going to be a factor of 1. So that means our list of possible rational zeros would be plus or minus 1, plus or minus 2, or plus or minus 4. Just because the numerator would have to be 4, and then we'd be dividing by 1. Second thing to do is start trying, and that's where we're going to use synthetic division with 1, 3, -3, 3, and -4, and start going through our list. So the first one we'll try is 1. Bring down the 1. 1 plus 3 is 4. 4 minus 3 is 1. 1 plus 3 is 4. And 4 minus 4 is 0. Since 0 is our remainder, that means that we know what one of the zeros is, and we can start factoring f of x. In fact, we know that f of x now has to be x minus 1 from this from the first factor, and this part gives us the second factor, x cubed plus 4x squared plus 1x plus 4. Now we can factor that second one by hand. So the first one's still going to be x minus 1, but over here we can factor by parts, cut it in half right here, and factor out the x squared out of the front, and we're left with x plus 4. and then factor out a 1 out of the second half, and we're left with x plus 4. So this will be x minus 1 times x plus 4 times x squared plus 1. We can continue to factor if you're asked to factor this completely, because right now we can see what all of our zeros are. The zeros are obviously going to be 1 and negative 4, and from this factor, when we set x squared plus 1 equal to 0 and solve it, we see that x is going to equal plus or minus I. So those are our last two zeros, plus or minus I. That means that we have two more factors, x minus I and x minus negative I. So this is f of x when it's factored completely. That gives us our four zeros of 1, negative 4, and plus or minus I.